Hi, it's me again. My name is Chizsmath, and today we're going to be dealing with the simultaneous equation. Let's go. The simultaneous equation is a collection of equations that have more than one variable and we believe are pointing to the same problem or describing the same thing. So we're looking for a value of x and y such that if we substitute it into equation 1, you get 0. Substitute it into equation 2, you get minus 2. There are three methods for solving a simultaneous equation. You have the substitution method, the elimination method, and the graphical method. I would advise students to use the substitution method if one of your variable has the coefficient of 1, and that variable that has the coefficient of 1 is the one you should make the subject of the formula. It's a lot easier to deal with. It removes the clumsiness of dealing with fractions in some cases. So let's go into it. So in this case, I want to make, you can choose x, you can choose y in this case. But in this case, I'll make y the subject of the formula. So it means that y is equal to, I move x to this side, y is equal to minus x. I'll call this equation 3. So I'll take this, I'll substitute equation 3 and put it in equation 2. What will come out of it is that 3, we have 3x, then plus 4y. But we said that y is equal to minus x, so I'll put minus x here, is equal to minus 2. As you can see, I'll call this equation 4. As you can see in equation 4, there is no y here anymore. Technically, there's no y here. So what do we have? We have 3x minus 4x is equal to minus 2. Which means that minus x is equal to minus 2, means x is equal to 2. Now we take this value and substitute it back into any of these equations. I choose equation 3 because, it's easier to deal with. So from equation 3, y is equal to minus x, which implies that y is equal to minus x is 2. It means that which implies that y is equal to 2. So our solution is that x is equal to 2 and y is equal to minus 2, minus 2. Okay? So we substitute it here. X is 2, y is minus 2. So it means that x plus y is 2 minus 2, which is equal to 0. X is 2, which is 6. Y is minus 2, which is 8. So 6 plus minus 8 is equal to definitely minus 2. So we got it right. Let's solve another example. Okay, in this one, I'll call this one 1, we'll call this one 2. In this case, I'll use equation 2. In equation 2, I'll make x subject of formula, so it means that x is equal to minus 1 plus 3y. To write it better, it means that this implies that x is equal to 3y minus 1. So we take this, I'll call this equation 3. We take this and substitute it into equation 1. So we take equation 3, substitute it into equation 1. So we have that x plus 2y, this is x. So we have 3y minus 1 plus 2y is equal to 5. This implies that 5, we break this down, 3 plus 2, collect like terms, so you have 3y plus 2y, which is 5y, so you have minus 1 is equal to 5. Okay, we move minus 1 to the other side, 5y is equal to 5 plus 1, which is 6, means that y is equal to 6 over 5. We'll take this value and substitute it into I'll use equation 3 because it's easier for me. So since y is 6 over 5, it means that if y is 6 over 5, it means that, let me separate this. It means that x from equation, it means that x, sorry, my marker is misbehaving, is equal to 3y minus 1. So we know what y is. It means that x is equal to 3 into 6 over 5 minus 1. This implies that this is 18 over 5 minus 1. Okay? Now, if 1 is the same thing as, I can write 1 as 5 over 5. So it means that x, since the bases are the same, we can just subtract the top. So 18 minus 5 is 13. So it means that x is equal to 13 over 5. Okay? So it means y 6 over 5, x is 13 over 5. Let's see whether it's correct. We have x, which is 13 over 5, plus 2y. 2y is 12 over 5. 13 over 5 plus 12 over 5 is 25 over 5, which is equal to 5. We have x minus 3y. X minus 3y is 13 over 5 minus 18 over 5. 13 over 5 minus 18 over 5 is minus 5 over 5, which is the same thing as minus 1. So we are correct. In this method, what we're going to use to our advantage is that if you multiply an equation by a constant, the equation does not change. For instance, if I multiply equation 1 by, say, 3, I have 6x plus 3y is equal, 6x plus, 9y is equal to 12, okay? This equation is exactly the same with this. All values of x and y that agrees with this equation agrees with this equation. As a matter of fact, if you plot this on a graph and you plot this on a graph, it is the same line.
Now I'm going to prove that an equation does not change if it is multiplied all through by a constant. Okay, I'm going to prove this graphically. Okay, so let me just put an equation like, let's say I use 2x plus 3y equal to minus 2. Okay, now I'm going to multiply this by 8. So you have 16x plus 24y is equal to minus 16. So this is the first graph, this is the second one on top of it. As you see, it's basically the same line. So voila, that's your proof.
We're going to use this fact to our advantage. So what we're going to do now is, for instance, we pick x. What we're going to do here is to make the coefficient of x to be the same. Then we'll move from there. So want the coefficients of x to be the same. What do? I'll multiply this by 3. I'll multiply this by 2. If I multiply this by 3, x here will be 6x. If I multiply this by 2, x here will be 6x. Though we are multiplying everything, alright? We're multiplying everything. We're not just multiplying just coefficient of x. So 3 into this is 6x plus 9y is equal to 12. I'll call this equation 3. Multiply this by 2. We have 6x minus 4y is equal to minus 14. Now that we have this, we can subtract this equation from this equation or this equation from this equation. It doesn't matter. So what I'll do, call this equation 4. What I'll do is I'll say equation 3, any way you want to do it, doesn't matter. I'll say equation 3 minus equation 4. Okay? 6x minus 6x, group like term. 6x minus 6x, you have 0. 9y minus minus 4y, is 13y. 12 minus minus 14 is 26. It means that cancel both sides, you have that y is equal to 2. So we take this value of y like we did before and substitute it in any of these equations. I pick equation 2. Okay, I substitute into equation 2. What I have, equation 2 says that 3x minus 2y is equal to minus 7. So you have 3x minus 2, y is 2, is equal to minus 7. Is 3x minus 4 is equal to minus 7. Move 4 to the other side. We have that 3x is equal to minus 7 plus 4. 3x is equal to 3 minus 3x is equal to minus 1. So let's check. X is minus 1, so minus 2 plus 6, which is something as 6 minus 2 is 4. Minus 3 minus 4 is equal to minus 7. So we're correct. Let's do another example. Let's solve this problem. Call this equation 1, call this equation 2. So as to reduce confusion, I'll rearrange this to appear somewhat like this. I write equation 2 as move 3x here, becomes minus 3x, move 7 there, becomes minus 7. So I have minus 3x plus 4y is equal to minus 7. Okay. We'll call this 2. In this case, I'll eliminate y instead. To eliminate y, I want the coefficients to match. If I multiply this by 4, the coefficient of y becomes minus 20. If I multiply this by 5, coefficient of y becomes 20. So I'll go ahead. I'll multiply equation 1 by 4. So I have 8x minus 20y is equal to 0. I'll multiply equation 2 by 5. I'll have minus 15x plus 20y is equal to minus 35. Now, in this case, instead of subtracting, because the coefficient of y here is plus 20 and the coefficient of y here is minus 20, it will be a disservice to you to subtract. If you subtract, this becomes minus 20 plus minus 20, which is minus 40y. So y doesn't go anywhere. So the best option here is to add, because the goal is to eliminate y. So we're going to add these two equations so that y goes away. If we add equation 1, let me call this equation 3, call this equation 4. If we add equation 3 to equation 4, we're going to have 8 minus 15 is minus 7x, y goes away, this becomes minus 35, this cancels this, x is equal to 5. Since x is equal to 5, we take it and substitute it in any of the equation. I choose equation 1. I'll substitute it back into equation 1. In equation 1, we have 2x minus 5y is equal to 0. So I have 2x, x is 5. So I have 2 into 5 minus 5y is equal to 0. So I have 10 minus 5y is equal to 0. So I'll move 5y over there, which means 5y is equal to 10, y is equal to 2. Okay, so that is it for elimination method.
Okay, now we're going to learn the graphical method of solving a simultaneous equation. I'll use one of the examples we used before, which is x plus y is equal to 0, I think. Yeah, is equal to 0. First, we're going to plot the two lines, okay? So the second one is 2x plus 3y is equal to minus 2, okay? When we plot this, What we are looking for right now is the point where the two graphs intersect, which is this dotted line over here. So what we're going to do is look for what that point is. That point is, as you can see, it is x equal to 2 and y equal to -2, which agrees with the question that we solved initially. Let's do another example. So the example is 2x plus 3y equal to 4. And the second one is 3x minus 2y equal to -7. Okay, we plot these two graphs. Now we look for the point where the lines intersect. The lines intersect at -1, 2. So it means that the solution to the simultaneous equation is x equal to -1 and y equal to 2. That's all.
We have this problem that says if the equations ax plus by is equal to -4 and bx plus ay is equal to 1 are satisfied by x equal to 1 and y equal to 2. Find the values of a and b. So in this case, it is assumed we know x and y. Instead, we're looking for a and b that satisfies this equation. So we're not looking for x and y, we're looking for a and b. So the first step is to put the values of x and y into this equation. So put into equation 1, we have that we have a plus 2b is equal to -4. Put this into equation 2, we have that b plus 2a is equal to 1. So I'll rearrange this second equation. I'll rearrange it to look, to look like equation 1 in a way. So I have 2a plus b is equal to 1. Okay, call this equation 1, call this equation 2. So I'll use elimination method. I'll multiply equation 1 by 2. So if I multiply equation 1 by 2, I'll have 2a plus 4b is equal to -8. If I subtract equation to eliminate a, I'll subtract equation 2 from equation 1. So equation 1 minus equation 2, 2a goes. This minus this, you have -3b. This minus this is equal to 1 minus -8 is 9. So we have, if I cancel both sides, I have b is equal to -3. That's dividing both sides by -3. If b is equal to -3, I'll substitute this back into equations 1. So equation 1 says that a plus 2b is equal to -4. I'll substitute, I have a plus 2 into, I have -3 is equal to -4. It means this is a plus, this is -6 is equal to -4. So moving -6 to the other side, you have a is equal to 6 minus 4, which is, it means that a, which implies that a is equal to 2. So our solution is that b is equal to -3 and a is equal to 2. Okay, thank you for hanging with me today. Please like, subscribe, and till we meet again, which we definitely will. God bless you. See you.